All right, so today we are talking about multiplying and dividing rational expressions. You guys are going to be able to take the skills of simplifying rational expressions and applying them to multiplication and division of rational expressions. So we're still going to be doing the same stuff. We're still going to be factoring. We're still going to be simplifying. But now we're just incorporating multiplying and dividing. So that just means you're going to have more to factor, more to simplify. Okay? So let's go ahead and get to it. Multiplying rational expressions. When you multiply a rational expression, okay, you basically now have two fractions that are being multiplied to each other. So A, B, C, and D, they represent, like a quadratic or like a binomial or something. So what do? You just multiply them straight across, just like you would with any fraction. So you multiply A and C together and divide it by B and D. And yes, B and D cannot equal 0. Those will be your excluded values. So if I asked you to find your excluded values, you look at your two denominators and basically set both denominators equal to 0. Okay? So let's find the product. One thing you can do, especially if it's something as simple like example 1 is, just multiply straight across. Okay? 3 times 6, 18. What is x squared times x squared? X to the 4th. All over 4 times 9, 36. What's x times x to the 3rd? X to the 4th. Now, you've done your multiplying, but you still need to simplify, okay? Is there a number that can go into 18 that can also go into 36? It's actually going to be 18. 18 is the biggest. What's 18 divided by 18? 1. 36 divided by 18? 2. What about these x to the 4th? They cancel out. So my answer is just going to be 1/2. Okay? Yeah, these ones are pretty simple. When it's a monomial divided by a monomial, just one term, just multiply straight across and then simplify after that. Now, these will be the only problems that I tell you to multiply first and then simplify. Ones like example 2 or 3 or 4, try to simplify first before you multiply. Okay? So let's look at example 2.
That's going to be a big number.
Especially if I multiply first and then try to simplify. So let's simplify first. And to do that, we're going to need to factor every numerator, every denominator. Okay? So you're definitely getting your factoring practice in.
And you want us to put all that on this sheet of paper?
It actually, I promise you it'll fit. It'll fit. Okay? Unless you write like super huge. All right? So let's start at the top. First thing I look for when I factor is what? What can go into both of them? That GCF. What can go into 5x squared and 5x? 5. A 5x. So it's a GCF for the top. When I take out a 5x, what am I left with? Mine is, I still got to have something. 1. Remember, anytime the GCF ends up being an entire term, you need to have that placeholder there. Okay? Top's done. I got my bottom. Is there GCF? No. So I got to make my X. What number goes on top? On bottom? Don't say it yet. Think about it. The two numbers multiply to give you 10 that add together to give you a negative 7. I heard 5 and 2. Negative 5 and negative 2. So x minus 5, x minus 2. So again, just to recap, we're simplifying first before we multiply. Because to be honest, if we try to multiply 5x squared minus 5 and then 5x squared minus 3x minus 10, that's going to be too much. No. Because it didn't ask us to find our excluded value. And to be honest, I probably won't ask you to find excluded values when you're multiplying. The simplifying ones, yes. Okay. All right. This one up here, GCF. So I got another x. What goes on top? Negative 10, bottom. Don't say it yet. Think about it. What are my two numbers that multiply to give me negative 10, add together to give me negative 3? 5. Negative 5 and positive 2. So that's the top of the second fraction. Now let's do the bottom. An 8 and an x. So what am I left with when I take out an 8x? Plus 2. Mm-hmm. We've factored, okay? Now we need to simplify this. Now we can look, okay, what things do we have in common with the top and the bottom so that they can cancel out? Haley, you said what? X plus 2 on the top and the bottom. Is there anything else on the top that can cancel out with the bottom? Maybe not on each individual fraction, but remember, we're multiplying these together, so we can go across the fractions. I have an x minus 5 and an x minus 5. And I have this x here. I'm telling you, it feels so good when you factor out all this and all these things just cancel out. Is there anything in common with the top and the bottom? So now I can multiply, okay? And I'm not going to like multiply, like distribute over. I'm literally just going to write down what I have left. So on the top, I have a 5 and an x minus 1 left. I have an x minus 2 and an 8. And this is my answer. Mm-hmm. So whatever doesn't cancel after you factor, that's your answer.
That is not something.
Questions? All right. Let's look at this one. Okay? Again, simplify first before you start like multiplying, okay? At the top, is there GCF? But this is one of those special factoring things I talked about on Monday. They are both perfect squares. So just to recap, perfect squares, this is how they factor. What's going to represent A? X. What's going to represent B? Because you take the square root of each one. So the top factors down to be x plus 3, x minus 3. What about the bottom? Is there a GCF? It's a 5. And I'm left with an x plus 3. Good stuff. Wait. Let's simplify all the way first before we start canceling. Don't get excited. I know. It's exciting to cancel everything out. What about the top over here? 4. X plus 1, that's what I'm left with when I take out a 4. And then I got to do the x for the last one. Am I going too fast? No. Okay, what goes on top? Bottom? Think about it. Remember, I'm looking for two numbers that multiply to give me 12. Add together to give me negative 7. I got to multiply to give me 12. So I got to be negative 4 and negative 3. So remember, multiply for the top, add for the bottom. Not the fun part. At least fun to me. Fun to me. Okay, it's the little things I look forward to. All right. What cancels at the top and the bottom? I have x plus 3, x plus 3. X minus 3, x minus 3. Anything else? No. Not even with my numbers either, because there's nothing that goes into 4 that also goes into 5. So I just write what's left over. I have a 4, x plus 1 left on the top, a 5, and then an x minus 4 on the bottom. That's it. But I'm telling you, you're doing the same thing that we were doing with the simplifying. It's just now you just have more to cancel out and more to factor. So you're getting more practice with factoring, more practice when simplifying. You okay? Okay. All right. Now this last one, okay? Now remember, these are fractions that I'm multiplying. How could I rewrite this x minus 4? I can put it over 1. Turn this into a fraction, okay? And now let's factor. Can I factor 2x? Sure can. There's nothing I can do with 2x. But I can't factor that bottom. I do the x, 8 on top, negative 6 on the bottom, negative 4, and negative 2. So that's x minus 4, x minus 2. I already know 1's on my denominator over here. Can I factor x minus 4? No. It's even in parentheses to let us know it's already factored. And I can cross out the x minus 4. It's x minus 4. Anything else? That's it. That's how you multiply rational expressions. And it may be easier because you've already had that practice with simplifying them. Okay? No. If you did, though, it wouldn't be wrong. Questions on multiplying? No, well, dividing, to be honest, dividing just has one more step than what multiplying has. Okay? Just real quick, do you guys remember how to divide fractions? No? You're thinking of when you're adding. I think you're thinking when you're adding with the crossing. But you got to keep, change, flip. Y'all remember doing that? You keep the numerator, change division to multiplication, and flip the denominator. That's how you divide fractions. Okay? The same concept applies here with rational expressions. Okay? So when you're dividing, you're technically multiplying by the reciprocal of the second fraction. So you have to flip C over D. So it becomes D over C. And then you're just doing what we just did, multiplying. So AD over BC. Okay? Yes, same thing, but you just have to remember to keep. No, I'm gonna make that thick. Keep. Oh, no, that's too thick. Let's bring this back down. So you gotta keep, change, flip with this one, okay? Hope no one's hungry. Hope no one's hungry. Okay? So I have a dividing one. I'm gonna have to what? Keep this. Change the multiplication. And now this looks very similar to number 1 on the multiplying side, okay? Let's multiply straight across. What's x to the 4 times 15x squared? 15x to the 6. Very good. On the bottom, what's 5 times 7? 35x to the 5th. Okay? Remember, these are the only ones I suggest multiplying first and then simplifying. Okay? Is there a number that can go into 15 that can also go into 35? Okay, so then what's 15 divided by 5? 35 divided by 5. And what about my x's? All the way? There's going to be just one x left over. So then my final answer for this one is 3x over 7. That KCF is really big. Okay.
DF's definitely not proportional.
It's not. That was looking, it's like it's awkward. Okay. So we're good? Okay, so for this one, I'm just going to go ahead and I am going to flip it, keep, change, flip before I start multiplying, okay? If once you do this enough times, if you're like, oh no, I'm good, I can just go straight into factoring and I'll remember to flip, then that's fine, but it doesn't hurt to be too careful, okay? What I want you guys to do right now is I want you to factor every part of that, okay? So both numerators, both denominators, and then we'll come back together, okay? So I want to give you guys some time to factor, okay? So factor all of this. All right, so the top, how's the top factor?
You get a negative 5.
X plus 3, x minus 5, either order matters. What about the bottom? How does it factor? Keep the x minus 1 on the top. X plus 2, x plus 3. Okay, so with the bottom and the top ones, the ones that were the trinomials, two numbers that multiply gave me negative 15, add together gave me negative 2. That was a negative 5 and a positive 3. And then down here, multiply to give me 6, add together give me 5. That's 3 and 2. What does things cancel? X minus 1s, x plus 3. Anything else? Cool. So then I'm left with, for my final answer, on the top, only an x minus 5. And on the bottom of 3, x plus 2. Okay. So dividing, just one extra step, keep, change, flip, and then it's just like multiplying. Okay? But again, you gotta know how to factor. It's gonna be key. Key. All right? I'm gonna go ahead and keep, change, flip this. And then I want you guys to factor this one all the way. Okay, make sure you always keep, change, flip when you're doing division. Okay? Factor this one all the way down. Let's look at this number, example 7. How'd you factor the top? X minus 5, x plus 1. Over 5, x plus 1. Good. I leave the 2x. Very good. That is difference of perfect squares. Okay, realize that perfect squares and perfect cubes can be in these. Okay, so you got to know those special ones. What things cancel? X minus 5, x plus 1. Anything else? So then we're left with 2x on the top. Awesome. Good stuff. Now this last one I want to change just a tad bit. Just a little bit. Just a little bit. Instead of this as being a regular x plus 7, okay. So okay. Normally we put it over 1. Okay? Let's change it and let's say this was originally over 4. Okay? Just a little change. Just a little change, okay? We're still going to do what to start? Keep, change, flip. And then we're still going to factor. So when I flip this, this becomes over x plus 7, okay? How does the top factor? Negative 14 and 5. What two numbers multiply give me negative 14, add together give me 5.
Negative 7, negative 2.
7 and 2, wait, watch your signs. Negative 2, because I got to get a positive 5. So x plus 7, x minus 2. Does this one factor 2x squared? No.
4 over the x plus 7.
Because I told you to add it in there. So like add this in. I'm changing the problem just a little bit. Okay. So yeah, I made that up. I'm making a change to the problem. So make sure you make that change. Can I factor 4? No. Can't factor 4 number. What about x plus 7? Can I factor that? No. So, cross what out? X plus 7. Can I cross anything else out? Okay.
Yeah,
I can simplify. I want to change this to a 4 because if there's a number at the top and like a number like this at the bottom and something can go into both of those, you want to reduce. Okay? What number can go into 4 that can also go into 2? So what's 2 divided by 2? What's 4 divided by 2? So then my final answer is going to be 2x minus 2 over x squared. And I wanted to give you that example just in case you get something like this on your homework. You're not going to be like, wait, what do we do with this number? There you go. Okay? So that's how you divide. And I think it's easier because, we spent a little bit of time going over simplifying, trying to refresh your memory about factoring, because you're doing the same thing. I've just added in another fraction, giving you more options of things to cancel out. But that is how you multiply and divide rational expressions.